So we're going to talk about converting between polar and rectangular coordinates. So first, we'll go in the direction of polar to rectangular. Polar to rectangular coordinates. So we're going from r theta to an xy point. Because if we plot within, I'll put a little coordinate system over here for when we do an example. So, and I'm going to put some, looks like I have to go out a little more for my example. So if I put some radius of 1, 2 to put my polar on top of the xy. Okay. So I'm changing from polar into xy, and I'm going to put a little version in quadrant 1, so I'm just going to put a random r theta. So let's see what we would use. If this is r, this is theta. To find the xy, x and y values, I'm going to make this into a triangle. So think about what involves here's the x value, here's the y value. So how would I find the x one? So look at for theta here, that's the adjacent side and the hypotenuse. So if I set up cosine of theta, adjacent over hypotenuse, x over r. So to get the x value, I would always be doing r cosine theta. Similarly to find y, that's the opposite. So I would set up sine. Sine is x over r. Oops, sorry, y over r. Opposite over hypotenuse, y over r. So to get the y value, I would always be doing r sine theta. So let's do an example, see if that makes sense. So if I have the polar coordinate 5, 3 pi over 4. 5, 3 pi over 4. So I'm going to plot that. So 5, 3 pi over 4. So I'm going to first go 3 pi over 4, which is 135 degrees. And then I go out 1, 2, 3, 4, 5. So here is my point. So it looks like, just kind of looking at my sketch, I drop down. Well, with this being a 45, it should be about the same. 1, 2, 3, somewhere around 3. Between maybe 3 and 4. 1, 2, 3, 4. Obviously my drawing is not completely to scale, but somewhere around 3 or 4 for each of the values. So let's see what happens. So to get x, I'm going to do 5 cosine. Now here, so if I put in 3 pi over 4, okay, now in my calculator, I would need to make this 135 if I'm going to do my calculator. But let's say I'm going to do exact. Cosine of 135. Cosine of 135, right here, cosine is the x value. That's negative root 2 over 2. So I get negative 5 root 2 over 2. Now to see if that makes sense, let's actually calculate that. Negative 5 times square root of 2 divided by 2, that's negative 3.54 approximately. So what we said, somewhere around negative 3, negative 4. How about y? 5 sine 3 pi over 4 would be 5 times, for sine, that's a positive root 2 over 2. So 5 root 2 over 2, which is going to be approximately a positive 3.54. So the xy coordinates would be, well, exactly it's going to be the root versions, but I'm going to just put in the approximations. Negative 3.54, 3.54. And if we look, that kind of makes sense. Going over negative 1, 2, 3.5, up 3.5, I'm going to land in that same spot. What should happen? It's just writing it in the polar versus xy. Okay, how about, let's do another one. Let's do one more polar to rectangular. How about negative 2 pi? We want to change this to an xy. Okay, now this one, to get my x, again, negative 2 cosine pi, and to get my y, that's going to be negative 2 sine pi. So before we calculate these, though, let's think about where we're at. So we go to pi, right here, and then in the negative 2 direction, when its radius is negative, I have to go the opposite. So instead of pi going straight to the left, I have to go flip it around and go straight to the right. So there's my point. Okay, that's my polar coordinate. Which I can kind of just look at this and see, well, the xy value is going to be positive 2, 0, not negative. So the right 2, 0, that's my xy. Well, let's kind of check that out with my formulas. Negative 2 times cosine of pi is negative 1. So negative 2 times negative 1 is 2. For the y value, negative 2 sine pi. Sine of pi, the y value at pi is 0. So there's my 0. So there I get my xy of 2, 0. Okay. So this one, I mean, I didn't really have to work it out like this because I could just plot it and see exactly where I'm going to land. But if you want to kind of do a double check with the formulas, that works out. Okay, so let's go the other direction now. That was polar to rectangular. Now let's go rectangular to polar coordinates. Okay, so instead of xy, I want to have the point r theta. And again, let's kind of picture, well, what if right here I have a point xy? And just draw a little dotted line. Here's my x, here's my y. So I want r. So let's think about it. If we know x and y, how can I find r? Well, r squared equals x squared plus y squared. So r is going to be the square root of x squared plus y squared. And then how about my theta? So whatever my angle is, I would set up tangent, if I know x and y, I would do tangent, let me kind of jot this over to the side. Tangent of theta is y over x, opposite over adjacent. So to get my angle, I'll do tangent inverse of y over x. And then have to think about where exactly I am, what quadrant. Okay, so how about, let's do, for example, 2 and then negative 2 root 3. 2 comma negative 2 root 3. And it kind of helps to figure out 2 root 3. So let's do that in our calculator just to get an estimate. Root 3 is 1.73 times 2 is 3.46. So now I can plot that. So I'm going to be at a positive 2 and a negative 1, 2, 3.46. So right here, we'll keep that in mind. So to get my radius, I can do square root of 2 squared plus negative 2 root 3 squared. Square root of that. So I'm going to have 4 plus negative 2 squared is 4. Root 3 squared is 3. So that's going to be 12 plus 4 is 16. So my radius is in perfect 4. So that's kind of nice. So this distance right here, this radius is 4. So kind of going along my, if I did my polar coordinates down here, radius of 4, which looks about right. Now for my angle, now I had said here to use tangent of theta because 2, this is 4, negative 2 root 3. Okay, so let's do, really I could do sine, cosine, or tangent, but to be consistent here, let's do our tangent inverse of y over x. So negative 2 root 3 over 2. Or if I want to simplify this, tangent inverse of negative root 3. Okay, now if I look at my unit circle, figure it out from there, I can do that. Or if I put in my calculator, it's going to tell me negative 60 degrees. Okay, negative 60 degrees. Now I wouldn't leave it like that typically though. I could. 4 negative 60 gets me to that point. If I wanted though to have my angle be between 0 and 360, I think about, well, where is that between 0 and 360? That would be 300 degrees. Or even if I wanted to do radians, that would be, remember not a space, but that would be 4, comma, right here is 5 pi over 3. So any of those will work. Unless, you know, if it specifies to do it a certain way, then we should pick that exactly.